we found a sample, and it was, again, we're exploring in places where there were rivers and where there were lakes. And much as on Earth, we think that that's where we'd see signs of ancient life on Mars.
They're calling it the fingerprints of ghosts. NASA's Perseverance rover just found something on Mars that scientists can't explain. A rock formation covered in strange, leopard-like spots with chemical traces that whisper of ancient biology. This isn't a random pebble. It's sitting near Sapphire Falls, a site already known for water-carved cliffs and minerals that only form in lakes. The patterns look eerily alive, like fossils frozen mid-breath. Could these markings be the first solid clue of life beyond Earth? But before we understand why these findings left the world's top scientists speechless, we need to go back to a Mars that no longer exists. A world of water, warmth, and possibly life. What really happened there? When Mars was alive. Imagine standing on the shores of a lake wider than Manhattan, watching rivers carve through rust-colored mountains under a sky thick enough to breathe. That was Mars. 3.5 billion years ago. Not the frozen desert we know now, but a blue world, alive with movement. Rivers raged down from highlands through canyons like Neretva Vallis, a name borrowed from a river in Bosnia because, just like its earthly twin, it once carried torrents of water. That river didn't just flow, it shaped the planet. It carved its way into a 22-mile-wide lake, more than 100 feet deep, inside what we now call Jezero Crater. If you stood there back then, you'd see muddy deltas fanning out where the river met the lake, the kind of view that feels calm but hides something powerful underneath. Over time, those sediments settled into layers of fine-grained clay and silt, what scientists at NASA call the Bright Angel Formation. And that's not just poetic naming. Those layers are like pages in a diary written in mud, perfectly capable of trapping and preserving the faintest traces of microbial life. Now, here's the wild part. That Martian lake existed at the same time Earth's first fossils were forming. Same era, same chemistry, same basic ingredients. So the big question becomes, did life spark in both worlds at once? Or, as some scientists suggest, could life have jumped from one planet to another? Panspermia, they call it. The idea that meteorites blasting off Mars might have carried microbes to Earth, or vice versa. Think about that. Every human cell could carry a piece of a Martian origin story. And that's exactly why NASA picked Jezero Crater for Perseverance's landing. It's not random. It's forensic science at an interplanetary scale. When the UCLA team analyzed Perseverance's samples, they found proof of what they'd long suspected. Jezero didn't just fill once. It flooded and dried, over and over again. Each time it did, it created what scientists call habitable niches. Temporary oases where microbial life could have thrived before the waters retreated. Imagine microbes clinging to mud grains, hiding in pockets of clay, maybe even forming mats on the ancient shoreline. Perseverance's onboard instruments, like Sherlock and Pixel, have been detecting organic molecules inside those mudstones, the chemical fingerprints that could mean life was there. Billions of years later, those molecules are still waiting for us to read them. It's like a message in a bottle sealed under Martian dust, and for the first time, we finally have the tools to open it. But that paradise didn't last. Something went wrong. Mars began losing its atmosphere, 100 tons of it every single day, stripped away by the relentless solar wind. Without its magnetic field, the planet couldn't protect itself. Slowly, the air thinned, the pressure dropped, and the warmth disappeared. Lakes froze solid. Rivers turned to ghost channels, and if anything alive remained, it had two choices: retreat underground or vanish forever. Now, all that's left is silence, and the rocks. But rocks, remember, they hold chemical echoes, mineral scars, and even microscopic fossils, if we're lucky enough to find them. So the question now isn't just whether Mars was alive, it's whether that proof is still buried there, waiting for us to dig it up. Fast forward 3.5 billion years. The Perseverance rover rolls across the dried bones of that ancient lake. And on July the 18th, 2024, it finds something that makes scientists around the world hold their breath. What exactly did it see? The rock that changed everything. They call it Chayava Falls, an arrowhead-shaped rock measuring just over 3 feet long and 2 feet wide, sitting in the exact spot where that ancient Martian river once poured into Jezero Lake. At first glance, it looks ordinary, just another piece of weathered basalt. But under Perseverance's laser and camera suite, the rock revealed something no one expected. A surface covered in pale, leopard-like spots. Each one, just millimeters wide, was arranged in clusters that looked eerily organic. Not random, not geological, almost patterned. Now, here's where things get weird. NASA's Sherlock and Pixel instruments started analyzing those spots and found they weren't just color variations. They were chemical fingerprints. Inside those tiny circles were elevated levels of carbon compounds and magnesium-rich minerals that, on Earth, almost always form in the presence of life. Think microbial mats around a hot spring, or the mineral crusts left behind by biofilms. Scientists at Imperial College London called them potential biosignatures, the strongest yet found on Mars. When Perseverance drilled into the rock and took a sample, it got even stranger. The internal chemistry didn't match the outer surface. It suggested that something had once seeped into the rock, something reactive, rich in organics, maybe even alive. The formation's micro-textures looked like mineralized tubules and veins, the same kind we see in stromatolites here on Earth, which are basically fossilized microbial communities. National Geographic described it best. It's as if the rock remembered being alive. Each dark speck is a frozen moment of possible biology. And the name Chayava Falls, that came from its location, an ancient delta channel named after a real waterfall on Earth. Only this one, billions of years old, could be hiding the proof that Mars once had not just water, but ecosystems. Even the team at NASA couldn't hide their shock. They ran every possible test to rule out contamination, lighting tricks, and even instrument errors. Nothing explained the formation naturally, and when they compared the data with samples from Jezero Crater and the riverbed near Neretva Vallis, the chemistry matched up, suggesting that whatever caused those spots wasn't isolated. It might have been global. A planet-wide signature of something once living. So what does this mean? If those leopard spots turn out to be biosignatures, this wouldn't just be the first evidence of life on Mars. It could rewrite the entire timeline of life in the solar system. It could mean Earth's spark wasn't unique at all. But here's what makes this discovery truly extraordinary. It's not just what they found, but what those tiny leopard spots reveal about how sophisticated Martian life may have been. Because if those markings are what scientists think they are, Mars may not have just hosted microbes. It might have once had ecosystems, and the clues hiding inside Chayava Falls might prove it. So, what exactly are those spots telling us about ancient Martian intelligence? The two-course Martian meal. Those leopard spots and poppy seeds, they're telling us a story about ancient microbes that were smarter than anyone expected. See, when NASA's Perseverance team started breaking down the Chayava Falls data, they noticed something wild. The chemical structure wasn't just random mineral buildup. It looked layered, almost deliberate. Think of it like a two-course meal written in rock. The outer crust was packed with vivianite, a blue-green phosphate mineral that forms when organic matter reacts with iron in water. Inside that, they found greigite, an iron-sulfur compound often created by microbial metabolism here on Earth. Together, those two minerals tell a secret story of energy flow. something feeding on something else. That's not geology. That's biology. An astrobiologist at Caltech even described it as a frozen biofactory, where ancient microbes may have cycled energy the way bacteria do in Earth's deep ocean vents today. Picture tiny Martian microbes, maybe living in mud along a river delta, taking in minerals from the water, processing them, and leaving behind a chemical fingerprint that still glows under NASA's SHERLOC laser billions of years later. And the best part? Those chemical fingerprints match something we've seen before. Back in 2025, Curiosity detected long-chain carbon molecules, big, complex organics that are usually found in biological processes. Scientists now think Chayava's mineral sandwich could have been the protective crust that kept those fragile organics safe from radiation all this time. It's almost like the microbes built their own armor before Mars dried up. This discovery forced NASA to rethink how simple Martian life might have been. Instead of random bacteria clinging to existence, we could be looking at organisms smart enough to adapt, shifting between chemical energy sources depending on the environment, like switching from solar to battery power. If true, that means Mars didn't just have life, it had survivors. Think about it. Earth's early microbes built stromatolites, layered colonies that turned sunlight and minerals into food. Chayava Falls might be Mars' version of that, a frozen record of something once alive and thriving, leaving behind a molecular mural we're only just learning to read. The same kind of pattern recognition that makes us go, wait, that's not random, is exactly what NASA's AI tools picked up on when processing those images. And that's why the planetary scientists are losing it. Because if the Vivianite and Greigite formed through biological means, it suggests an entire food chain once existed. Tiny Martian microbes feeding off minerals, excreting chemical energy, and layering themselves into patterns that fossilized into those spots we're staring at today. It's no longer a question of whether Mars could have supported life. It's starting to sound like it did. But here's the twist. For all the clues Perseverance has uncovered, the real proof, the smoking gun, still lies sealed inside its core samples, waiting for Earth-based labs to confirm it once and for all. So, when will those samples return home for definitive analysis? That's where this story takes an unexpected turn, one involving budget crises, international competition, and a race against time itself. What's really standing between us and the biggest discovery in human history? The race against time. NASA's Perseverance rover may have uncovered the most compelling evidence of ancient life on Mars. But there's a catch. The proof is locked inside those tiny rock tubes it drilled, and bringing them home has turned into one of the most chaotic science missions in modern history. What started as the decade mission has now become a bureaucratic nightmare that even NASA admits could take decades and cost billions more than planned. See, the Mars sample return mission was supposed to be simple on paper. A lander would scoop up Perseverance's sealed samples, launch them into Martian orbit, and a spacecraft would ferry them back to Earth. Easy, right? Except it's not. The original plan ballooned to a staggering $11 billion and wouldn't return the rocks until 2040. That's 15 years from now. By then, many of the current scientists leading the research might not even be around to analyze them. So earlier this year, NASA hit the brakes. After an internal audit tore the mission apart for being too complex and too expensive, the agency did something rare. It opened the floor to outsiders. More than 60 private and international teams were invited to pitch faster, cheaper alternatives. That's when the race began. Europe's ESA, which had been building the retrieval lander, started quietly distancing itself, hinting at new directions and possible reallocation of assets. Translation: they don't want to go down with a sinking ship. Meanwhile, over in China, the Tianwen-3 mission is shaping up to steal the show. Their goal: launch in 2028 and bring back Martian soil by 2031, nearly a decade before NASA's timeline. If they pull that off, the first hand to hold proof of life on Mars might not be American at all. The irony? NASA already has the evidence right there on the surface. Perseverance is literally sitting on the jackpot, but no working way to bring it home. And every month that passes, those samples face potential risk from Martian dust, radiation, and even mechanical degradation inside their tiny titanium containers. So NASA is scrambling. They're testing cheaper landers, considering drone-style retrievals, and even using AI to design faster rocket stages. The mission has become less about engineering and more about pride. Who will plant the first scientific flag on this discovery that could rewrite our entire understanding of life? Because if Perseverance's samples truly hold microbial fossils, the clock isn't just ticking on technology, it's ticking on history. But even as we race to confirm ancient life, another discovery suggests something far more unsettling. Mars might harbor living microbes right now, hidden beneath the surface. Could that be true? The hidden ocean time. So here's where things start getting truly bizarre. For years, NASA believed Mars was bone dry, a dead rock sealed under dust. But new radar scans from orbit flip that theory on its head. Beneath its south pole lies a buried ocean, liquid water stretching for hundreds of miles. Not ice, liquid. It's trapped nearly a mile below the surface, under frozen layers so thick they act like a planetary thermos. And here's the twist. Scientists think it's salty, supercharged with minerals, and possibly still geologically active. Imagine this. Under that frozen Martian ice cap, there's an entire ocean that hasn't seen sunlight in billions of years. The kind of place where microbes could hide from deadly radiation, still quietly alive. It's like Antarctica's subglacial lakes, but red, alien, and ancient. Scientists at Berkeley even joked that if life ever wanted to go underground and wait it out, that's exactly where it would go. Now, mix that with another mystery: methane. NASA's Curiosity rover caught huge spikes of methane near Jezero Crater, and nobody can figure out why. On Earth, methane almost always means biology, bacteria breathing, digesting, living. But on Mars, it vanishes as quickly as it appears. One week, it's there in massive plumes. The next, it's gone. Some think it seeps out from those underground aquifers. Others believe it's coming from deep subsurface life that wakes up only when temperatures rise. It gets even crazier. Curiosity recently drilled into sulfur-rich rocks, minerals that form only when water and life interact. These rocks look like chemical fossils, proof that Mars didn't just once have the ingredients for life. It may still be cooking something down there. The sulfur might act like a microbial battery, feeding tiny organisms that never see the surface. If that's true, we're talking about a biosphere hidden miles deep, powered by chemistry instead of sunlight. Think about what that means. We could be sharing a solar system with an alien ecosystem that's been quietly surviving under ice while our own species learned to walk. That buried ocean isn't just water, it's a time capsule, a frozen memory of when Mars was alive. Every radar ping we send through that ice brings us closer to a truth humanity's not ready for. We might not be the first or only spark of life in this corner of space. Ancient life, possible living microbes today. But there's a darker possibility scientists are only beginning to confront. What if life on Mars caused its own extinction? The cautionary tale. Here's the part that almost nobody talks about, because while everyone's buzzing about ancient Martian microbes and frozen oceans, scientists at the University of Arizona dropped a theory that's equal parts brilliant and haunting. They think early life on Mars might have thrived, and then accidentally triggered its own extinction. Yeah, you heard that right. Mars might have killed itself. According to new simulations, ancient microbes probably lived off hydrogen and carbon dioxide, two gases that kept Mars warm enough for liquid water. The problem? Those microbes may have been too good at their job. As they multiplied, they pulled those gases out of the atmosphere faster than volcanic vents could replace them. The result? The air thinned, the planet cooled, and the very life that made Mars habitable ended it. It's like nature's version of unplugging its own life support. Evidence backs it up. When orbiters mapped the ice buried deep inside Martian craters, they found frozen layers that read like pages in a planetary diary. Each layer shows how fast Mars' climate shifted, from warm and wet to freezing cold in geological minutes. NASA's latest data reveals the same story. The planet once had a thick atmosphere, a magnetic field, and even rain. Then something tipped the balance. It didn't just lose its warmth, it lost its soul. You can't help but wonder, what if that's not just Mars's story? What if it's a mirror? We're sitting here, pumping carbon, altering our skies, melting our poles, and saying, we've got time. But Mars once said the same thing, right before it didn't. The red planet isn't just a mystery out there. It's a warning label, floating in space, showing us what happens when a world forgets how to take care of itself. So where does this leave us? Standing on Earth, looking at Mars, wondering about the fingerprints of ghosts. What if those ghosts aren't from another world at all, but a glimpse of our own future? If Mars really did host life that shaped, then destroyed its own world, the next big question isn't, did life exist there? It's, could it come back? Because NASA's new biosignature readings at Chayava Falls might not just prove past biology, they could hint at dormant microbes waiting for warmth to return. Imagine that. Mars, frozen but not dead. So what if the red planet isn't just our mirror? It's our future waiting to happen. Share your thoughts in the comments. And if you like this story, subscribe and turn on notifications so you don't miss updates on more fascinating stories.